Okay, welcome to spring semester. So today we're going to be talking about sampling distributions. There's quite a bit of terminology we want to make sure we keep straight as we go. But what we're going to start with is we're going to pretend like I have a fifth period stats class that is very small with only 4 students. And their scores on the last test that we took were a 60, 70, 80, and 90. Very convenient. And I'm going to make a dot plot. So here's the first thing we do with our dot plot is I give it a title, population distribution of scores, 60, 70, 80, and 90. I suppose I could put 100 on here too. And I'm going to put a single dot to represent each individual score. So this is one individual score of a 90. Okay? And next, we want to take a sample of any two of the scores and find the mean of our sample. I'm just going to take the first two, so 60 and 70. The mean of that is 65. And the symbol we use for the mean is X bar. So X bar tells us it is a sample mean. Let's label that also. So that is the mean from my sample, or my sample mean. Okay, figure out all the possible combinations of size 2, calculate a sample mean for each sample of 2. So what that means is all the different ways I could combine 2 out of the 4 scores. So I could have a 60 and a 70, I could have a 60 and an 80, a 60 and a 90, a 70 and an 80, a 70 and a 90, and then an 80 or a 90. So let's jot those all down. Okay, and here are all my different combinations of 2 samples and the average of each one. Now, each one of these, again, is called X bar, and X bar represents statistics. I know it's about time we got to that, right? Statistics. And statistics simply means it comes from the sample. We get parameters from a population, we get statistics from a sample. So S and S for sample and statistic, P and P for parameters from a population. Okay, we want to make a dot plot using each of the means that I found up here. So I'm going to make a dot plot similar to this, but instead of putting a dot representing an individual score, each dot's going to represent a mean. So let me go ahead and sketch that and you can see it. Okay, so here is my sampling distribution of X bar, which is the sample mean scores. And notice that I had 2 that were at 75. So I have 2 dots right there at 75. Each individual dot represents one sample mean. This one is with the score of 85. This would be a sample mean of 65. Let me keep going here. What is the mean of the population? Well, of course, to find the mean of the population, I take my population, add them together, and divide by the number of elements in the population. So I get 75. The symbol I use for this is my population mean now. I've taken all 4 elements of my population, is mu. Mu is your population mean. So it's from every single one in the population. So that's your parameter. And if I want to put that on the chart above here, so right here is 75, and my mu value is 75. So our statistic is an unbiased estimator when the mean of the sampling distribution equals the parameter. So the mean of this sampling distribution was 75. That's right. That was where our peak was. And my population mean I just calculated was 75. So this tells me that my statistic here is a good estimator of my population because they fall at the same spot. Okay, let's turn this over and fill in our learning targets for this. Okay, again, we're going to have 3 different learning targets. The first one is definition of parameter and statistic. Parameter is a number describing a population. Statistic is a number describing a sample. And for both parameter and statistic, we could have a mean, For a parameter, we would use the symbol mu. For a statistic, we would use x bar. We could have a proportion. If it's from a parameter, or a population, it's going to be a p. If it's from a sample, so it's going to be called a statistic, it's going to be p hat. And finally, we could have a standard deviation for either a parameter or a statistic. So if it's from the population, we're going to use this symbol. If it is from a statistic or from a sample, we'll just use lowercase s. Okay, let's do learning target 2. Okay, second learning target is a sampling distribution. So sampling, ing there, shows the statistic found in all possible samples of size n. So all the possible combinations we could have from the population of a sample size n. So on the previous example from my imaginary 5th period class, that would be a sample size of 2. A sampling distribution, we put a title on there, so it's the sampling distribution of whatever your statistic is. Each dot represents the statistic from a single sample. And the sample could have had 10, it could be the mean from 10, it could be the mean from 2. It could be a proportion, we'll get into that later on. But it's from the sample. It's not an individual element from the population. Okay, and then finally, we have learning target number 3. The third one is that our statistic is an unbiased estimator if the mean of the sampling distribution is equal to the parameter. So as long as the statistic is the same as the population parameter, then we know that our statistic is an unbiased estimator. And also, just as a side note, that if we increase our sample size, then our sampling distribution variability, the spread of it, will decrease. And I'll be showing you something in class around that in a little later class where you can see it. But go ahead and try and do this check for understanding before you look at my answers. Okay? And hopefully you have paused this so you could do the check your understanding yourself. But I went ahead and just gave them each letter to represent each kid. And I want to create all the possible combinations here. So this is each combination. So J with each of the other kids, then A with the other ones except for J, because we've already done that. Then Michael with Erica and Michael with Sarah, and then Erica with Sarah. So those are all the 10 possible combinations if I take 2 at a time from this sample of 10. Or I end up with a sample of 10 if I take 2 at a time from the population of 5 elements. We wanted to calculate the mean of our sample, so I went through and calculated that. Sampling distribution, there's our title. Here is my dot plot. And we do want to make sure we leave these ones blank that have no data. So we don't just squish it together and ignore those points. The mean of the sampling distribution. So this is the mean of the sampling distribution, so of all the means. So I've added all of these 10 together, divided by 10, and I get 12.8. The mean of the population, I take each individual one, add them together, and divide by 5, and we get 12.8. So notice that we have the same value here. So that tells us that the sample mean is an unbiased estimator because they are equal. And what if we used a sample size of 3 instead of 2? Well, first of all, there'd be less possible combinations here. But if you increase your sample size, you decrease the variability of the sampling distribution. So instead of being spread from 8 up to 17, it might have been from 9 or 10 to 15. We'd have to do it to find the exact numbers, but it would decrease that variability. Okay, and we are going to do a second one today, so there's a second video for this. I hope this makes sense and it's becoming fresh in your minds again.